Good morning, everyone. This is Super Bee Science on the way to Jackson, Tennessee. There are three ways, count them, three, to describe motion. The first is number 12. Correct. Words. Yes, words can describe motion. Words in sentences, paragraphs, lab reports, vignettes, roll call, essays, etc. The second way, count 'em, the second way to describe motion is number 3. Yes, formulas, equations. Some of your personal favorites for one-dimensional motion. Speed equals distance over time. V equals D over T. Average velocity equals XF minus XI over TF minus TI. And of course, average velocity equals VI plus VF divided by 2. And your favorite formula for acceleration. The change in velocity over the change in time. V sub f minus V sub I over T sub f minus T sub I. Rearrange and you get Vf equals Vi plus At. Mix them up again and you have another favorite formula for motion. Change in x equals 1/2, open parentheses, Vi plus Vf in the parentheses times change in time. Rearrange them again and substitute. Change in x equals, what is it? V sub I t plus 1/2 a, change in time squared. You got it. And last but not least, one of your favorites, I know, because you have squared in it. Yes. V sub f squared equals V sub I squared plus 2a change in x, and there you have it. Your basic formulas for one-dimensional motion. And the third way to describe motion, the first being number 19, yes, words. And the second being number 5. Yes, formulas and equations. And lastly, number 23. And the answer is yes, graphs. Graphs. The third way to describe motion is graphically. I love it. Yes. Well, first let's start with a position time graph. Now let me say first that all of our motion graphs will have time as the independent variable on x. Always time, usually in seconds, will be on the independent axis x. And on the y-axis will be the other variables that we'll talk about this bright sunny morning. Position, velocity, and of course acceleration. So first let us start with position time. Now, there's only 2 basic things you need to know in physics. Horizontal, this away, and vertical, this away, indeed. Now, don't be confused when we talk about change in position. It can be in the x direction, or it can be in the y direction. However, we plot the change in position always on the y-axis on the graph. Let me repeat so you don't get confused. Our change in position can be in the positive x or the negative x direction, or it can be in the positive y or the negative y direction. But that position on the graph is always plotted on the dependent axis, the y-axis. Got it? Got it. Good. Super B science rolls on. So let's look at the position time graph. If you have a line that is parallel to the x-axis, horizontal, it shows on a position time graph that you have, number, let's see, 18. Absolutely correct. Zero velocity, velocity of zero, because there is no change in position. Nothing changes on the y-axis. You have a flat line parallel to the x-axis. Excellente. If you have a diagonal line on, no matter how steep or how shallow the slope, it shows a change in velocity. A change in velocity. And if it moves away from the x-axis, it is positive. And it moves towards the x-axis, it is negative, a negative velocity. And last but not least, for position time graph, the slope of a position time graph represents, number 8. Yes, of course. Average velocity. The slope of a position time graph represents average velocity. And let me add parenthetically that if you have a parabola on a position time graph, it represents acceleration, of course, which brings us now to velocity time. And you will of course remember that time will always be on the independent axis, the x-axis. So therefore we only have one other choice. On the dependent axis will be velocity, usually in meters per second. Here we go. Are you ready? Let's start with that horizontal flat line parallel to the x-axis. It will represent number 19. Yes. Waiting. Of course. Constant velocity. That flat line parallel to the x-axis will represent constant velocity. If it is in the first quadrant above the x-axis, it will be a positive constant velocity. If it is below the x-axis in the fourth quadrant, it will be negative constant velocity. And of course, you will assume that if it's on the x-axis, it will be a constant velocity of number 14. Of course, zero velocity if it is on the x-axis. Yes. So what does that leave us? That leaves us a diagonal line. No matter how steep or shallow the slope, it represents, of course, a changing velocity, which is number 13. Waiting. Acceleration. Ding, ding, ding. Of course, that is correct. If it moves away from the x-axis, of course, it'll be a positive acceleration. And if it moves towards the x-axis, it will be a negative acceleration. Ding, 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 ding. Of course, you've got it. And I might add parenthetically, if there is a parabola, which there never will be in this class, this elementary class in physics, it will be a changing acceleration or jerk like there are in this class. There are a few jerks, but no jerk. Gotta love it this early in the morning. And of course, class number 1, again, way to describe motion. Number 13. Words, yes, words. And the second way to describe motion, yes, number 4, of course, listen. Equations and formulas. Woohoo! Yes, all right, here we go. We're almost home. Although I'm not anywhere close to Jackson. I haven't even made it to Grenada. All right, here we go. The third graph is acceleration time. Of course, acceleration time. If you have a line that is flat line, horizontal to the x-axis on an acceleration time graph, and of course, acceleration is on the number 3. Yes, the dependent axis y. Acceleration is on the dependent axis y. Woohoo! Yes. So if you have a flat line parallel to the x-axis, what do you have? What do you have? Number 5. Woohoo! Number 5. Listen. Constant acceleration. Ding, ding, ding. Of course, constant or uniform acceleration if the line is flat, horizontal to the x-axis. And of course, if it is above the x-axis, it is positive acceleration. And if it is below the x-axis, it is negative acceleration, where you will find gravity acceleration to the gravity, because it's always negative as you move towards the Earth or any other planet in the universe. Yes, indeedy. And I might add parenthetically, if you have a diagonal line, no matter how steep or shallow the slope on acceleration time, you have, yes, you all know it, jerk, yes, which we won't cover in this elementary physics class. So to recap it all, wrap it up and send it out on the airwaves, the first way to describe motion is words. The second is formulas or equations. And finally, the third way, my personal favorite, is graphically. Thank you very much for listening. This is Super Speed Science.